Hi students, welcome to KSN Classes. Today we'll discuss a few more topics on circles which will be useful for the board examinations, for the intermediate and CBSE and all, and also for the mains, advanced also. So now I'll discuss chord of contact. I'll discuss the chord of contact. What is meant by chord of contact? Let SC is equal to 0 be a circle. Let Px1 y1 be an external point. Be external point to the circle. Let PA comma PB be the tangents drawn from P to the circle. The secant AB is called chord of contact of P with respect to S equal to 0. That I mean to say, I will consider a circle. This is a point P x1 y1. P x1 y1 will be an external point. The tangent drawn from P is meeting the circle at A and B. The join of AB, the chord AB or the secant passing through AB is called chord of contact of P with respect to the circle S equal to 0. The definition can also be written in a different way. Let Px1 y1 be an external point to the circle S equal to 0. The two tangents drawn from P meets the circle at A and B. At A and B. The secant AB is called chord of contact of P with respect to S equal to 0. So this is the definition. So let P be a point outside the circle. Let the circle be S equal to 0. Now the tangents drawn from P to the circle are meeting at A and B. These are the points of contact of P with the circle, point of contact of the tangents drawn from P to the circle. The join of these 2 points A and B is called the chord of contact, or this chord is called the chord of contact, or the line passing through it. That is, the secant through A and B is called the chord of contact of P with respect to S equal to 0. Now we will prove the theorem for the chord of contact. We will prove the theorem of the chord of contact. I will consider a circle. Let this be S equal to 0. I will take a point Px1 y1 here. it is meeting the tangents drawn from P are meeting the circle at A and B. Okay, statement random. Let us write the statement. The equation of chord of contact of Px1y1 with respect to s equal to 0 is s1 equal to 0. Let us see this. This be a point Px1y1. Now in the proof we will consider point Px1y1. The two tangents are drawn from P to the circle because it is an external point. The tangents are meeting the circle at A. Let the point A be x2, y2, and similarly this is x3, y3. Now, it is not possible to find out the equation of the tangent drawn from P directly because the tangent drawn to a circle at a point means the point must be on the circle. So you can find out the equation of tangent to a circle at the point A as s1 equals 0. Now, let A x1, x2, y2, comma B x3, y3 be the points of contact of tangents, point of contact of tangents drawn from P, x1, y1 to the circle S is equal to 0. Now, these 2 points are on the circle. You can find out the equation of circle at the point A. Now, equation of circle A x2 y2, equation of the tangent at A x2 y2 on the circle S equal to 0. That is xx2 plus yy2 plus g into x plus x2 plus f into y plus y2 plus c equal to 0. You can call this as 1. Similarly, equivalent tangent at B x3 y3 on the circle S equal to 0 is xx3 plus yy3 plus g into x plus x3 plus f into y plus y3 plus c is equal to 0. You can call this as 2. Now both the tangents at A as well as B are passing through a point P. Since one passes through P, Px1 y1, we have x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c equal to 0. Call this as 3. Here, 1 is passing through P. That means P is supposed to satisfy the equation 1 because 1 is the equivalent of tangent drawn to a circle at the point A. It is passing through a point P. Therefore, P must satisfy the equation. That means you have to replace x and y with x1, y1. Similarly, 2 also passes through P. Then we have x1, x3 plus y1, y3 plus g into x1 plus x3 plus f into y1 plus y3 plus c equal to 0. You call this as 4. These are the conditions that we obtain by the given data. Because it is given that the point P is outside the circle, Therefrom we are drawing two tangents which are meeting the circle at A and B. The join of AB is called the chord of contact. Now our intention is to find out the equation of the chord of contact of P. So because the point A is on the circle, I considered the tangent of circle at A as well as at B. By the condition, by the data or from the figure, it is very clear that the tangent drawn at A also at B, both are passing through a point P, and therefore we got two conditions. Now we'll consider an equation. Consider xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. Let me call this as 5. This is 5. Now I will rewrite it in a different fashion. x1 plus g into x. I am taking the x terms at one place. y1 plus f into y1 plus f into y, plus gx1 plus fy1 plus c is equal to 0. It is nothing but it is in the form of ax plus by plus c equal to 0. So it is a first degree equation in x comma y, which represents a straight line. Which represents a straight line. So this fifth equation is representing a straight line. Now we will see whether this fifth equation, the fifth equation is passing through A and B or not. Now from 3, if I write x2 here, it will become x2 x1, y2 y1 plus g into x2 plus x1 plus f into y2 plus y1 plus c equal to 0. From 3, it is clear that 5 passes through A. From 4, it is clear that 5 passes through B. So the 5 is passing through A as well as B, and it is a straight line. So the straight line 5 is passing through both A and B. Therefore equation of AB is S1 equal to 0, comma, equation of chord of contact of P with respect to S equal to 0. So this is about the equation of the chord of contact. So here we have taken the external point and the points of contact of the tangents drawn from P, and therefrom we have extracted the equation of the chord of contact. So this is about the chord of contact. Now I will write a few points on it. I will write a few points on it. Number 1. If P lies outside the circle, then chord of contact of P, exists and intersects the circle in two distinct points. That is one. Number 1. If P is on the circle, there is no possibility to draw two tangents, because whenever P lies on the circle, the two tangents PA and PB will be coincident coincide and will be passing to the point P. Therefore, if P lies on the circle, the chord of contact of P, the chord of contact of P with respect to circle coincides with the tangent at P. Now the third point. If P lies inside the circle, whenever P lies inside the circle, there is no possibility to draw any tangent. If you can draw any tangent, then only we will see whether two tangents are possible from the point or only one tangent is possible. If the point is outside, two tangents are possible. If the point is on the circle, the two tangents will be coincident and will be coincide with the tangent at P. If P lies inside the circle, no chord of contact of P exists with respect to the circle. So these are the findings of this theorem. So this is one theorem. Okay, I hope it is clear. Now I will discuss one more theorem, that is the equation of the chord having the midpoint. If the midpoint of the chord is given, how to find out the equation of the chord. One more theorem, I will discuss one more theorem. Okay, the next theorem is the equation of the chord of the circle S equal to 0 having mx1 y1 as midpoint is S1 is equal to S11. Let us see. I will consider a circle. This circle is S is equal to 0. Let this be the chord AB. It is said that the midpoint of this chord is given. Let me call mx1 y1. Let this be the center of the circle C minus G minus F. I will join this. I will draw a perpendicular and this perpendicular will be meeting at midpoint only. Now, I have to find out the equation of the chord AB. To find the equation of this line, I need the point and slope. I have already given mx1 y1 as the midpoint of this chord AB. That means a point is given. Now I need the slope. For that, slope of here, what we'll do is the circle is S equal to center C minus G minus F. Slope of CM. What is M? Already it is given M as the midpoint there. So y1 plus F by x1 plus G implies slope of AB. Slope of AB. This is equal to minus of x1 plus G by y1 plus F. Since CM is perpendicular to AB, so slope of AB is equal to minus 1 by M, where M is the slope of CM, where M is the slope of CM. So this is one formula. Slope of AB. Now equation of AB. Equation of AB. This is the point y minus y1 is equal to minus of x1 plus G by y1 plus F into x minus x1. Y minus y1 into y1 plus F is equal to minus of x1 plus G into x minus x1. Let us expand it. y1 plus Fy minus y1 square minus Fy1 minus xx1 plus x1 square minus gx plus gx1. We'll bring the negative signs on this side to this side and negative to that side. xx1, I'll bring it here, plus yy1 plus gx plus fy is equal to x1 square plus y1 square plus gx1 plus fy1. Actually, this is the end of the theorem, but it becomes very difficult to remember. So, according to notations, we'll add something on both sides so that to convert it to S1 is equal to S1. So, adding gx1 plus fy1 plus c on both sides. On both sides. xx1 plus yy1 plus gx1. So g into x plus x1 plus fy1 plus c is equal to ex1 square plus y1 square plus gx1 plus gx1 plus 2gx1 plus 2fy1 plus c. That is equal to, it implies S1 is equal to S1. Therefore, this is the equation of the chord having M as midpoint. The next theorem is the combined equation of the pair of tangents drawn from Px1 y1 to the circle S equal to 0 is S into S1 equal to S1 square. Let us consider circle. Let P be the external point. Let P be a external point whose coordinates are x1, y1. Let a tangent drawn from P be meeting the circle at A and another tangent be meeting at B. Let C be the center. This is S equal to 0. You join AB. AB is the chord of contact whose equation is S1 equal to 0. So, here equation of AB, that is equation of chord of contact of P x1 y1 with respect to S equal to 0 is S1 is equal to 0. That is the equation of S1 equal to 0. Now we need the equation of the combined tangents, that means the pair of tangents drawn from P. So let us consider some point Q somewhere on this pair. Let this be Qx2 y2. So I am choosing Q somewhere, whether it may be here or maybe here or somewhere. Now this PQ, this line S1 equal to 0 is dividing PQ at the point B in the ratio. Now B, so AB divides, let Qx2 y2 be a point on the pair of tangents drawn from P, drawn from P. Now AB divides PQ in the ratio PB is to QB is equal to minus S11 is to S12. Minus S11 is to S12. Of course, if the point is on the other way, this can also be taken as S11 is to S12. And depending on the internal division and external division. That I mean to say, PB by QB is equal to modulus of S11 by S12. But we know that PB and QB are the lengths of the tangents from P and Q. But PB is equal to length of tangent from P to S is equal to 0. To S equal to 0. That is root S11. Similarly, QB is equal to length of tangent from P to S equal to 0, root S22. It implies root S11 by root S22 is equal to modulus S11 by S12. Now squaring on both sides, S11 by S22 is equal to S11 square by S12 square. So you can cancel this one. So this is S11 into S22 is equal to S12 whole square. S12 whole square. Now S into S11 is equal to, now locus of Q is the equation of pair of tangents. Equation of pair of tangents. That is S11 is into, this is a S into S11 is equal to S1 square. S1 square. So removing this locus of Q, you will find S into S11 equal to S1 square. So this is different.